Hello students, we are going to design and configure Opamp in inverting amplifier mode for gain 10 and non-inverting amplifier mode for gain 11. The apparatus required are function generator, DSO, DC source, LM741 IC and resistors. This is the circuit diagram of inverting amplifier. Some portion of the output signal is fed to the input via the feedback resistance RF. Input signal is fed to the inverting terminal of the IC via resistor R1. Grounding is given to non-inverting terminal. Plus 15 volt is given to pin number 7, minus 15 volt is given to pin number 4 and output is taken from pin number 6. Let's see the theory behind for calculating the value of input and feedback resistor. The expression for gain is ACL closed loop gain, which is equal to minus RF upon R1. Let the amplifier to be designed with a gain of minus 10. Then we'll select the input resistance R1 equal to 10 kilo ohm. Therefore, the feedback resistance will be minus in bracket gain multiplied by the input resistance. Putting the value of gain and input resistance, we will get 100 kilo ohm as the feedback resistance. Similarly, the amplifier to be designed with a gain of minus 20, then the feedback resistance RF will be minus 20 multiplied by 10 kilo ohm, we will get 200 kilo ohm. So, the value selection of resistors is significant for designing an amplifier. The other expression for gain is equal to ACL, which is equal to output voltage upon input voltage. So, the output voltage is nothing but gain multiplication with the input voltage. That means if the input voltage is 1 volt peak to peak and the gain is minus 10, then the output voltage will be minus 10 peak to peak voltage. So in this way, gain is playing an important role for the amplification of the input signal. Let's implement the circuit and observe the waveforms. This is IC741. Pin number 1 starts from notch and it will go up to pin number 8 in this manner. 100 kilo ohm resistor is connected between pin number 6 and 2. Input resistor is connected between pin number 2 and the input signal. Minus 15 volt is given at pin number 4 and plus 15 volt is given at pin number 7 and the common ground is given to pin number 3. Input signal is taken from function generator where sine wave is selected having frequency 1 kHz and 1 volt peak to peak. One of the input signal is fed to the input resistance and the other is given to channel 1 of DSO in order to see the input signal. The grounding is given to pin number 3. Output signal is taken from pin 6 and it is given to channel 2 of DSO. From the waveform, we can observe that the output signal is out of phase with the input signal and the output voltage is the product of gain and the input voltage. Here, the input peak to peak voltage is 1.24 and the output voltage is 10 times the input voltage, which is 11.80 volt. So in this way, Opamp is amplifying the input signal in inverting amplifier mode. Let's design the Opamp for non-inverting mode with gain 11. The expression for gain is given as ACL closed loop gain, which is equal to 1 plus RF upon R1. In order to design the amplifier with gain 11, we will select R1 equal to 10 kilo ohm Hence, the feedback resistance will be ACL minus 1 in bracket multiplied by R1. So putting the value of R1 and gain, we will get the feedback resistance is equal to 100 kilo ohm. Similarly, if we select R1 equal to 1 kilo ohm, then the feedback resistance will be 10 kilo ohm. So the output voltage will be 11 times the input voltage. Let's see the circuit diagram of non-inverting amplifier. The input signal is fed to the non-inverting terminal of IC and some portion of the output signal is fed to the inverting terminal of IC via feedback resistance RF, and R1 is connected between inverting terminal and the ground. Output is taken from pin number 6. Let's implement this circuit diagram and observe the waveforms. In this circuit, we will just interchange the inputs between pin number 2 and pin number 3. That means the input ground and the DC common ground is connected at input resistor R1 and the signal is given to the pin number 3. By observing the waveform, we can say that the output signal is in phase with the input signal and the output voltage is nothing but gain multiplied by the input voltage, which is 11 multiplied by the 1 volt peak to peak. So in this way, Opamp is amplifying the input signal in non-inverting mode.